All right, let's look at some reference angles in radians. So the nice thing about reference angles in radians is for angles that we really mostly care about, they actually work out really nice every time. So for angles like 5 pi over 6 or 3 pi over 4 or 4 pi over 3, right, where it's some special angle, like the pi over 4s, the pi over 6s, and the pi over 3s are special angles, the reference angle is almost always just 1 pi over whatever the denominator is. So for 5 pi over 6, I know the reference angle is pi over 6. 5 pi over 6 is almost pi, right? It's 5/6 of pi. So we know we're in quadrant 2. So there's 5 pi over 6. And then how much more do we need to get to pi? Well, we need 1 more pi over 6. You can also do the subtraction, right? Pi minus 5 pi over 6 is 6 pi over 6 minus 5 pi over 6, which is pi over 6. Same idea here. 3 pi over 4 is also in quadrant 2. Because again, it's not a whole pi, but it's definitely more than half a pi, right? It's 3/4 of a pi, and a pi is halfway around the circle. So I know I'm somewhere in quadrant 2. There's 3 pi over 4, and I need 1 more pi over 4 to get the whole 1 pi, or 4 pi over 4. Again, you can also do the subtraction. Pi minus 3 pi over 4 is 4 pi over 4 minus 3 pi over 4, which is just pi over 4. Same is true for 4 pi over 3. So 4 pi over 3 is in quadrant 3, right? It's more than a whole pi. It's 4/3 of a pi. So more than a whole pi, but not more than 1.5 pies, right? This is 1 1/3 pies. Spits me right there. In fact, I kind of like to think about it as I've got 1 pi over 3, I got 2 pi over 3, I got 3 pi over 3 is 1 pi. And then I got 4 pi over 3. So I want 1 more pi over 3, so my reference angle is pi over 3. Or you can do the subtraction, right? 4 pi over 3 minus pi is 4 pi over 3 minus 3 pi over 3, which is just 1 pi over 3, which is just this angle right there. 19 pi over 6, again, since it's a something over 6, I know my reference angle is going to be pi over 6. Here I have to work a little bit harder because it's kind of an angle that's bigger than 360, so I got to think about where it lives. So 19 pi over 6, 1 full revolution is 2 pi, which is 12 pi over 6. So that's 12 pi over 6. And then I still have 7 pi over 6 to go. So 7 pi over 6 is still more than a whole pi. So I'm going to go another 6 pi over 6 and then 7 pi over 6. I end up in quadrant 3. So I could do it this way. In fact, what I should do is probably just do 19 pi over 6 minus 2 pi, which is 12 pi over 6, gives me a 7 pi over 6. And then 7 pi over 6 is in Q3, and then I do 7 pi over 6 minus pi to get 1 pi over 6. And I'm going to say this multiple times. For radian angles where it's some multiple of pi over 3, 4, or 6, and it doesn't reduce, right? Like 4 pi over 6 would be really 2 pi over 3. But if it doesn't reduce, then the reference angle is just pi over the denominator. So the reference angle for 5 pi over 6 is pi over 6. Reference angle for 3 pi over 4 is pi over 4. Reference angle for 4 pi over 3 is pi over 3. Reference angle for 9 pi over 6 is pi over 6. Reference angle for 73 pi over 4 is pi over 4. Because it doesn't reduce, right? 73 is odd, 4 is not odd. And yeah. Now for these other weird angles, we actually have to do some more of the work, really. So 11 pi over 16, I know it's not a whole pi, but it's definitely more than half a pi. So it's going to be in quadrant 2. And I really just think about how much more do I need to get to a whole pi. So I have 11/16 of pi. I need 5 more 16ths. Or you can do the subtraction. Pi minus 11 pi over 16 is 16 pi over 16 minus 11 pi over 16. And 16 pi minus 11 pi is 5 pi over 16. 12 pi over 9 is a little bit more than pi. Now, I'm silly here. I should reduce this. 12 pi over 9 is 4 pi over 3. Let's make it more interesting. Let's make it something that doesn't reduce, like 14 pi over 9. That's a little more interesting. So 14 pi over 9 is, I think that's going to be in quadrant I didn't want it to be in. But that's okay. So 14 pi over 9 is definitely more than a whole pi, right? There's 9 pi over 9, 1 whole pi. And then I've still got So this is a good question. So am I in quadrant 2 or am I I'm in quadrant 3 or am I in quadrant 4? Well, if I subtract off just pi, I'm left with 5 pi over 9. But 5 pi over 9, 5/9 is bigger than a half. So really I'm actually in quadrant 3. So here's my 14 pi over 9. So I'm trying to find this angle here. I'm not going to subtract pi and get 5 pi over 9 because 5 pi over 9 is bigger than a reference angle can be. 5 pi over 9 is bigger than 90 degrees or pi over 2. So I have to do this. So this is 2 pi. So 2 pi minus 14 pi over 9 gives me 2 pi is 18 pi over 9 minus 14 pi over 9, which is 4 pi over 9. Okay, this one I'm going to change just so it's more what I want. Let's make it 17 pi over 12. So 17 pi over 12, also bigger than pi. Right, it's more than 12 pi over 12. But it's not bigger than 1.5 pies. Because 1.5 pies would be 18 pi over 12, right? If I do 17 pi over 12, there's 12 pi over 12. And then I still have 5 pi over 12 left, which isn't quite isn't quite half a pi. So I get to like right there. So I know if I subtract off pi, that's going to be 17 pi over 12 minus 12 pi over 12, which is going to be 5 pi over 12. And the point I kind of want to make about this is that if you do the wrong thing, like let's say I thought that was in quadrant 4, and I did 2 pi minus it. If I did 2 pi minus it, I would get 7 pi over 12. But then I would say to myself, oh, 7 pi over 12 is bigger than pi over 2, so that's not right. My reference angle can't be bigger than pi over 2. And I've got one more over here. I've kind of used up all my room. So let me erase this and write 4 pi over 9 up here. There's my reference angle there, 4 pi over 9. That's right there. So here, 53 pi over 10, that's definitely more than a whole revolution. In fact, I think it's more than 2 revolutions, right? Because 20 pi over 10 would be 1 full revolution. So there's 20 pi over 10. Another revolution would be 40 pi over 10. And then I still have 13 pi over 10 left. So 10 pi over 10 gets me halfway around. So there's another. Right? Alternatively, you can subtract off as many 2 pi's as you want. So I'm going to subtract off 2 pi twice. So I'm going to subtract 4 pi because that's just 2 full revolutions. It doesn't actually change what the reference angle is. And that's going to give me 53 pi over 10 minus 40 pi over 10. 53 minus 40 is 13. And 13 pi over 10, like my picture was showing, there's 10 pi over 10, or 1 whole pi. And then I've got a little bit more. How much more? 3 pi over 10 more. So I could just see it's 3 pi over 10, or I could do 13 pi over 10 minus pi, which is 10 pi over 10, to get me 3 pi over 10. So there's the reference angle for 53 pi over 10, which ends up terminating in quadrant 3. All right, so there's how you find reference angles for radian measures. It can be really nice for these special angles where it's something over 3, 4, or 6. It's a little bit jankier for the ones where your denominators are something else. So yeah, these ones you usually get something times pi over 12 over 16, whereas for these other ones, you just get 1 pi over 6 or 1 pi over 3 or 1 pi over 4, which is kind of great.